good. Thank you. So we're gonna do this together, and it's really like mostly Mark, and just me starting and then finishing this, and obviously the clicker stopped working. Now it's working again. This is like, where's Gabor? Yeah, it's like Cider V2. Okay, now the clicker works again. Yeah, as I said before, we're gonna kind of give you a bit of an overview where we were a year ago, roughly a year ago, a bit less than a year ago. Talk a bit about where DuckDB is at the moment. We're going to talk a bit about adoption, how people out there are using DuckDB, or at least the numbers that we can observe. And as I said, we're also going to talk a bit about what we are kind of planning. And since you're here, you have a chance of influencing the where we're going actually. So if 10 of you get together and say bombard us with requests for one specific feature,
it'll probably work.
It's probably will work. So just saying. And of course we have a Q&A in case there's any questions. Okay. And with that, I will hand over to Mark.
Thank you very much. Yeah, well, thank you everyone for coming. It's very nice to do this in person. But I think the last DuckCon was also a great success, but I think it's great that we get together and talk a lot more afterwards and grab some nice Belgian beers as well. All right, so I want to start off with the slide where we finished in last DuckCon. I'm not sure, have people here, have some of you here attended the last DuckCon over Zoom? So you may vaguely remember this slide. And this was kind of like our goal list. It's not quite a year ago, it was in April, so it's roughly 10 months ago. And this was kind of the list of the goals that we had set for ourselves, of the things we wanted to solve in the next year. So I think a big theme of what we have been trying to do is get this whole out of core thing working, which essentially means always making progress on queries and never running into out of memory exceptions, right? So there's one, of course, one of our goals is to basically be able to squeeze as much out of a single machine, out of a laptop as possible, so that you can always get your queries running without having to resort to any sort of like distributed system setup that's very complex to set up, very complex to run. But of course, that comes with limitations. Namely, you have one computer, you have X amount of memory, but you usually have Y amount of disk, which is much bigger than X. So kind of the idea behind this out of core story is that we can in a streamlined manner, go from memory to disk while still always making progress on the query and never running into out of memory exceptions. And that's something we have been working on very hard, and that's something that was our goal last year. Another important thing that we have been trying to do, unfortunately still haven't succeeded, but hopefully this year we're going to do it, is to finalize the storage format and go towards this DuckDB v 1.0. So we're now on DuckDB v 0.6, and it's kind of what we're hoping to achieve with our own custom storage format is that it will be able to be used in a similar manner to SQLite, where I can send you a DuckDB version, you can send it to your coworkers, you can send it to your friends, you can send your DuckDB file to your mom, if she's a data scientist, and you will be able to read it, and you won't actually have to care about which version of DuckDB you're running, right? Today, that's unfortunately still not a reality, and the reason for that is that we want to have our storage format be as good as it can be, and once you say this is it, like we're not making any more like breaking changes, you kind of lock yourself to a specific format, including all its drawbacks. So we have been trying very hard to improve the storage format and reach a point to where we actually feel comfortable saying, this is our storage format, this is what we're going to settle down on. That was already our goal last year. It is still our goal this year. You will see it later. We have been making progress on the storage format, and we are today a lot happier with our storage format than we were back in April of 2022. Part of the storage format finalization is, of course, also the compression methods, right? So we have been working very hard on getting the DuckDB storage format to be smaller to compress data, right? And that's also something that's very important if you want to squeeze the most out of one machine, is to be able to say, reduce your data set size basically for free, right? Because that's what lossless compression is. You can have a data set that's maybe like 10 gigabytes in CSV file, and if you add some compression routines on top, you can reduce that to 3 gigabytes, so 2 gigabytes. You can get like a factor 4, factor 5 reduction in data set size, and that matters a lot because it greatly expands the amount of data you can process on your one machine. So we have also been looking to improve that. Another thing that we have been wanting to solve is like, well, solve is a hard word. You can't really solve joint ordering. They have been trying for 40 years to improve. Is joint ordering, right? So we used to always have a pretty okay joint order optimizer, but our cardinality estimation was not that top notch, and we have been wanting to improve that so that the system can more cleverly reorder joints if you have complex SQL queries. And that's quite important because reordering joints manually is very painful. So you kind of hope that the system does the right thing by itself, right? And that's also one of the things that we aim to do, is to make DuckDB very easy to use and basically try to get it to do what you want it to do without having to like tinker things. And that includes, of course, the joint order. So that's one of the things we have been wanting to solve as well. And finally, one of the goals we had was to get our index persisted and a bit redesigned, fixed, so that the indexes could be constructed and kept around, right? So what we used to have back in 2022 was that if you had an index, like primary key index or an index you had created, it would rebuild it on startup, which is very painful, especially if you have a very large data set. Because, well, rebuilding an index, very expensive, so persisting it, great, you can just use the one that's there. So in the last 10 months, we've had 3 major releases. We had one in June, we had one in September, and we had one in November. We actually did a release, I think it was 2 days before the last DuckCon. We have tried to make a release right before this DuckCon as well, but unfortunately it's going to be a week out from now. But I will talk about it anyway. These are the things that are out right now that have been out for a while, right? So we had 0.4, 0.5, and 0.6. Maybe also one change you've noticed is that we've switched to a semantic versioning scheme. So we used to have 0.3, 0.3.1, 0.3.2. We're now going up to 0.4, 0.5, 0.6, 0.7. So there's more like logical progression in version numbers. And hopefully reaching that 1.0 this year. That's still like a big goal of ours. So I want to kind of quickly go over some of the improvements that have come with this. Maybe you have also seen some of them, maybe you have enjoyed some of them, but I would just like kind of give a bit of an overview of the cool stuff that some of our engineers have been doing. And it's really our engineers. That's also, I think, one of the big changes that has happened that Hannes will tell more about later, and also you can see if you look around the room, is that it's no longer just well, me and Hannes and Pedro hacking around. It's actually, we actually have like a bigger of a team now, so it's a lot more of a collaborative effort, which is very cool because all these people are extremely smart and they're doing some very cool work, which I can now talk to you about. And yeah, also for each of these changes, I want to like say who has worked on this, because I think it's, if you are interested in one of these topics, maybe you can look up a team member and ask them some cool questions, or ask talk about your favorite features, so to say. All right, so let's get things started. So the storage improvements. Well, like I said before, one of our big goals has been to finalize on the storage version. So we have been working hard at improving the storage. And one of those was the persistence of indexes. So that's was back in July, and that was done by Pedro. You can see there's a nice picture of him dressed like Bob Ross during our Bob Ross outing. The reason, by the way, why this is relevant to the index is that our index is called an art, and this is art. Yeah, that was one of the cool features that we had, was to persist art indexes to disk. And that's also kind of, it sounds kind of simple, right? Like, how do you persist an index? Like, this has been done before. But it was actually not super simple, because the index that DuckDB uses, an adaptive radix tree, is a very like novel, like new index that came out of academia very recently, and originally was designed as purely an in-memory structure. So it is actually not super straightforward. We actually had to do quite some hacking around to get this to persist in a novel manner, as opposed to something like a B+ tree, where people have been persisting these things and paging these things for I don't know, 40 years probably. That has already been done before. This was actually a bit more of an effort. But of course, the reason we use the art is because it has advantages over B+ trees. Like, it actually does reduce the footprint of the index, it does some like compression, it does some faster lookups. So yeah, that's one of the big changes we had, was that these things are actually persistent. Another big change we had was that we support parallel data loading now, which is quite nice. You can see there's some numbers where in v0.6 we enable this, and the data loading, well, it scales with the amount of cores, right? It's parallel. And that's quite nice. That's one of the things that also sounds quite easy, but is actually the result of like quite a long rework we did of the storage, where we moved towards a more like row group oriented storage system that now allows us to construct these things fully in parallel, fully independent from each other to achieve like very nice scaling. And you can see that if you do like bulk insertions, bulk create table, they are faster now. And that's also, yeah, again, one of the improvements we have been wanting to do to the storage, because I think right now, you've probably seen this yourself as well, like parallelism, it's kind of required, right? Because your laptops, they come with like 10 cores now. Like doing things single-threaded is just too slow, right? So we have been wanting to move, like everything needs to be parallel in order to be fast. And that's also something we have been working towards, is adding more and more parallelism to the system so that everything can benefit from your hardware to like its maximum extent. All right. Something else we have been working on a lot is compression. So data compression in our storage format when you load data into that. And you can see that we did I ran some numbers using some popular data sets. I don't know if it's too small maybe to read. These are from a blog post that I wrote that's also on our website, where you can see the data size of loading specific data sets into DuckDB over time, essentially. And this is the compression of our storage format. It was first introduced in September in 2021, so that's roughly 1.5 years ago. And since then, we have progressively been adding more algorithms. And the reason for that is that, of course, if you think of compression as a user, maybe you think of like, oh, I can throw gzip on it, or zstandard or something like that. But that comes with like performance downsides, right? Like there's some cost to decompressing, and we have been opting to do a like more lightweight, specialized compression routines, which has the benefit that decompressing is very fast, reading the data is very fast, but has the downside that you need to implement many of these algorithms, right? So if you use zstandard, you just throw zstandard at it, it compresses it, and you're good. But it comes with a performance downside. We have been trying to get kind of like a best of both worlds, where we have all these specialized algorithms that do this compression, and the system kind of automatically detects which one to use. Again, we don't want to have users have to specify things. We want to have things as easy as possible. But of course, it takes time to develop all these algorithms. And Sam and Thijs, our engineers, have been very hard at work at making some very cool compression algorithms, including the frame of reference we have. We have FSST, which is invented by Peter here, who's also here, and Chimp and Padas for floating point compression. And if you're interested in like the technical workings of all these compression algorithms, there is a blog post where I explain in detail more about all these individual things. And you can see in this graph, you can see that as time goes by and we get more and more of these algorithms, we improve them, that the compression ratio of the file format goes up and up, and the dataset size goes down and down. And we're still not done. We still have some new ideas for compression, but it's already looking quite cool. It's already kind of, our storage format is approaching the size of Parquet, even though Parquet is using these general purpose compression algorithms. So yeah, that's quite neat to see. And as a result of using these lightweight compression algorithms, it's faster to read from our own file format than it is from Parquet, right? Like that's one of the main advantages of this. All right, then the memory management improvements. This is more of like a general thing. We have been working very hard to get DuckDB to, well, never run out of memory, right? Like I said before. One of our goals is to squeeze as much as possible out of your laptop, out of your server, out of wherever you're running. And well, your laptop has maybe 16, maybe 32 gigs of RAM. If you want to operate on bigger data sets, you need to do, well, sometimes you need to do clever things. And how clever these things need to be kind of depend on what kind of operations you're doing and the size of these intermediates, right? So for example, if you're doing like aggregations without any grouping, like I'm doing a select count, then it's very easy to have a streaming solution, right? Like you just look at a batch, you say, oh, I have 10 elements, you go to the next one, you can just read as you go. That's kind of the initial, like DuckTV's engine, DuckTV's streaming engine kind of guarantees that already works. But then you run into all kinds of edge cases where things get harder, right? Like what happens if I do a join on two tables, but both tables are bigger than my RAM, right? Like now I can't fit my hash table in memory anymore. What happens if I do an aggregation and I have 1 trillion groups and I only have 1 billion bytes of RAM? Yeah, something like that. Then also your hash tables don't fit in memory anymore, and you need to do some more clever things. So Lawrence has been hard at work on what we call making these operators work out of core. And the goal of that is that basically we don't lose any speed in the case where the operator does fit in memory, where the intermediate does fit in memory, but it will gracefully start offloading as much as it needs to disk, and you as a user won't even realize it's happened, except that maybe there's like some performance degradation, like it slows down a bit, right? At least depending on your hard disk. If you have a very fast SSD, maybe you won't even notice that much, right? Like we, on the latest MacBooks, if you're running like a very fast SSD, they can get pretty close to like RAM speeds, like gigabytes per second. So it will still complete very fast, even with this disk offloading. And so the very first operator we made out of core was the sorting, and that we already had last time. And what we've added, what Lawrence has added this year, is the out-of-core hash join operator, where our hash join now also supports the case where you have both tables being bigger than memory. And Richard, who's not here unfortunately, has been working on the out-of-core window operator, which also relies on the sort code, right? So that if you run a window function on a table that's bigger than memory, it will also offload to disk. We've also made like general improvements to memory. So index memory usage has also been a sticking point, and that's what Tanya has been working on. She's added like better memory tracking to the index, so the system is aware of how much memory the index is consuming, and can offload other blocks to disk so that you don't run out of memory. And we've also worked on the optimistic writing to disk, which means that if you stream like very large files to a DuckDB database, it will now already start writing to the database even before the transaction has committed, right? So that was one of the limitations we had before, is that the transaction state, like what is in one transaction, would first not be written to disk, but would be like materialized, and only after, when the commit is called, it would write it to disk. But that is a problem, because if I load like a giant Parquet file, right, or a giant CSV file, or what have you, that doesn't fit in RAM, then that doesn't quite work, because then you end up not streaming the data directly to disk. So what we do now is we do this, what we call optimistic writing to disk, where we kind of assume you're going to commit, which usually is the case, and then we just write the data to disk even before the commit has been done. And after the commit is received, we just say, oh, it's already there, great. And then everything can be done in parallel, and you don't need to materialize anything in memory. You can stream directly to the database file. So that's another improvement we've made to the storage system. All right, well, we've also been doing a lot of performance improvements. That's also something that, of course, one of our goals is for DuckDB to be a very fast engine on a single node, right? And we were always at work on optimizing the system, seeing, trying to detect things that may not be running as optimal as possible, and making them fast, making them streamlined, right? So one of those things is, of course, the join order optimization improvement. So that's something that Tom has been working on during his master thesis. He has been working on essentially re-engineering DuckDB's cardinality estimator and making it like really top-notch and competitive with other database systems such as Postgres. So that's something that now, if you run queries that have many joins, DuckDB should be able to reorder them in a much better way, which will lead to great performance improvements, right? That's one of those things that if you do these kind of optimizations, you can easily get like a 10x performance improvement or 100x performance improvement just from running the joins in the correct order. It's one of those big impact sort of changes if things go right, or big negative impacts if they go wrong. So that's a very big thing. Pedro has been working on parallel CSV reading. That's something that we have gotten a lot of requests for. That's out now already, but it's still experimental. We are still working on finalizing it and improving especially the error handling around it. So it already works, but yeah, one of the things with CSV files is that there's a lot of like weirdness in them, right? Like if you're familiar with CSV files, things go wrong a lot, and it's very important that the error reporting is very robust and very easy for the user to act on, right? Like so that we can say, hey, something is wrong in this file on this line. That's something that if you run it, like single-threaded, is much easier because you just go, okay, line 1, line 2, line 3. But if you run in parallel, this becomes a bit harder. So that's something we're still working on to make well, as good as the single-threaded reader, or even better. Like we're trying to improve that as well, of course. So we're hoping to move this out of the experimental stage and into the actual CSV reader. Probably not with the next release, which is in a few days, but for the next one. Sam has been very hard at work on improving our HTTP and S3 reader layer. So if you read Parquet files over from an S3 directly or from an HTTP connection directly using DuckDB, that should be just automatically much faster now than it was a year ago. We've been doing a lot of cool stuff with that to make that as fast as possible. And yeah, we have been like parallelizing a lot of things that weren't parallel before, such as, well, the index creation. Tanya's been working on that. Thijs has been working on making the distinct aggregates parallel, right? So if you do a count distinct, now DuckDB runs that in parallel. It didn't a year ago. And the result set materialization now runs in parallel. So if you have a big result that you want to push to a pandas data frame or so, that should be parallel now as well. And yeah, many more. We have been parallelizing a lot of things actually. So there's like a long list of things that have been improving. And there's a little table with like, well, showing how, if you have a few threads, the CSV reader gets faster now, at least if you enable the experimental CSV reader parallelization. Oh yeah, we have also been adding a lot of new features, of course. I won't list all of them, but just some features that that I think are quite neat that we've added in the last 10 months. The first one is the from first syntax. So this is something we've added to DuckDB. So normally, of course, if you see a SQL query, it starts with select. That is the way things have always been. But of course, sometimes you don't really need to select anything, right? Like if you're just trying to see the first few rows of a table, you don't actually want to select anything, so you just do like a select star. And that's supported now by DuckDB, where you can just leave out the select star and you can directly select from a table. So you can do like from table limit 10, and that's a valid query. You don't need to put the select star there. You can also put a select there, but in my personally for me, that just looks wrong if you have from select, but that does work as well. But for like quick getting a feel of a data set, this is pretty nice optimization. You can also do like from a Parquet file, etc. And also one of the nice things about this syntax is that potential auto-completion can be better if you start off with the table function, with the table, right? Because if you say, okay, I'm reading from this table, then the auto-completion can say, okay, now I can only fetch columns from this table, whereas if you do the select first, then it doesn't know which tables you're going to read from. Although our own auto-completion doesn't take advantage of this yet. Lambda functions and list comprehension, that's a very cool thing that Tanya has worked on as well. So we have been working a lot on nested types in DuckDB as well, so like lists and structs and maps, and that's something that DuckDB has gone quite good at over the last year. And we now support also list comprehension, which is like the Python style list comprehension, where you can essentially run a Lambda function over all the entries in a list, right? So you can see it there, you can take the uppercase of a name for every name in the movies, you can apply a filter as well. And that's all using the Lambda functions under the hood. So that's very cool. And one cool feature that Mox has implemented is the union type. So that's now, in DuckDB, of course, all of our columns, everything is strongly typed, but we now also support the union types or the sum types. There's a lot of different names for this in different languages, where you can basically say, okay, I have a column, it has one of these types, right? It's like, for example here, I have either a number or an error message, right? Like that's a potential use case you can use for that. And that's also something that's potentially useful if you're going to implement an extension to use it like a backbone, like a physical backbone for a type, like a more complex type. Cool. All right. So those were all the things we have done in the last year. Now I want to talk about well, the next to be scheduled release on February 13th. We haven't decided on a duck yet, so of course every one of ours every one of our releases comes with the name of a duck, so we don't know who that duck is. But I want to just like show some of the new features that are going to be in the next release that you can expect. So one of the things I've been working on is multi-database support. So essentially, since, well, DuckDB's inception, we've always been limited to having a single running database, right? Like you connect to a database on startup and that is your database. And that's cool, but it has the downside that you cannot combine data from multiple DuckDB instances very easily. You cannot write data from one DuckDB instance to another. And it actually, it's kind of weird, but it made DuckDB's own storage format a bit of like a second-class citizen to Parquet, because you can't do these things with Parquet, right? Like you can read and write from multiple Parquet files, but you can't read and write from multiple database files. So that's something that I've been working on, is to get the attach and the multi-database support in. So you can now attach new DuckDB instances and operate on them. So you can attach a new database, you can write to that new database, you can transfer data between DuckDB databases. That's all going to be in the next release, and that all works. This is like how the syntax looks from a SQLite. To expand on that, I've also been working on getting pluggable catalogs and pluggable storage in DuckDBs, inside DuckDB, which means that when you attach a database, it doesn't actually have to be a DuckDB database. We can now also support different storage backends. So we have the SQLite scanner for a while, where you can read data from SQLite files. But starting with the next release, it's going to actually be the SQLite extension that adds support for SQLite storage. And what that means is that you can still query data from SQLite databases, but you can also write back to them. So you can attach a SQLite database, you can create tables in the database, you can insert data into the database, and you can use all of the normal like DuckDB constructs on SQLite database, right? Like you can use this to load a Parquet file into a SQLite database and transfer data between DuckDB and SQLite in either direction, right? No longer just one way. And that works like this. You basically attach a file and you specify that it's a SQLite database, and then it should work. It appears as if it was a normal DuckDB database. One of the things Laurens has been working on, which has also been quite heavily requested. That's good. That's the reaction we're hoping for, is JSON reading. So we've had JSON reading-ish for a while, right? So we have this read JSON objects feature, which allows you to read a bunch of JSON objects, but it doesn't decompose those objects. It doesn't like say, hey, these are the columns, these are the types of those columns, like the CSV reader, like the Parquet reader. And that means that you have to work with this JSON as if it's a JSON thing, which is not quite natural in SQL, right? Like in SQL, you want to work with tables, it's more natural. So that's one of the features that's going to be the next release, is we're going to have, parallel, very efficient JSON reading with auto detection. So you can just point DuckDB at a JSON file, and we'll try to figure out the schema of the JSON elements, right? By looking at the things, filling in nulls, I think, where things are missing, potentially, of course, it's a variable schema thing, and convert this back into a table. And it's all parallel, it's very efficient, and this is, going to be the next release. One of the things that Sam has been working on is Hive partitioned write support. So we've had read support for, that's one of the things that we've added this year as well. So Hive partitioning, for those that are not familiar, it's essentially a directory-based partitioning scheme for files, right? So for example, if I have a table, I can partition it, I can say partition by year and month, and it will basically create this directory structure and lay out the files according to the partitioning values they have in that directory structure. And it's called Hive partitioning because it originates from a system called Hive, of course, and it has been around for a while, and a lot of other systems also support it. We have supported reading from it for a while, but starting with the next release, we also allow support writing to this file partition format. So how you do that is you pass a partition by to the copy, and DuckDB will create this directory structure based on the files to wherever you specify, and put the data in the corresponding files. And then, of course, DuckDB can read it back in as well using the same support. Cool. Another thing we have in the schedule for the next release is delta compression. So that's another compression method that's particularly good for things like regular time series. And the idea is for this compression method that you look at the differences between the consecutive values, right? This is a very common compression scheme that's used in time series databases mostly. And this can greatly reduce the size of like sequences of timestamps or sequences of values. And it's something that's going to be in the next release as well. And here's kind of how this works laid out in storage. So if I have, for example, the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 in order, right? Instead of storing those individual numbers, I can just say, hey, these numbers, they start with 1, and there's a difference of 1 between them, and I have 9 of them, right? So then you can save a lot of storage space. And again, this is like just more like a back-end thing. The system will automatically check on loading data into a database. Hey, is this applicable to my data? If yes, it will try to use this to store the data. All right, and then we also have some new SQL features for the next release. Thijs has been working on the upsert support, so we will support upserts. Upserts are essentially like a combination of update and insert, right? It essentially means that if there's like a primary key constraint on your table, that you do like an insert or replace. So you basically say, if the value with this key is not there, you insert it. If it is there, you update it, like you replace it. There's also insert or ignore. We support both the SQLite and Postgres syntax, but this is just like kind of the simple syntax for this. That's going to be there in the next release. We're going to have lateral joins. This is a bit more tricky to explain if you're not familiar with them. Lateral joins, they're kind of like a more generic version of a correlated subquery. If that didn't help, then essentially what a lateral join is that you have a subquery on the right side that has a variable that refers to a previous entry in your from clause, and then it kind of does like a sort of join between this and this table. And the way you can kind of see it is that you can create a sort of query that acts as like a function that acts on your previous data set. So that's kind of how you can see it. It's a bit tricky, but we're going to support it. So yeah, some people get very excited about this, but most people, I guess, are not familiar with them. All right. Then one feature that Richard has been working on is the positional join. So this is something that's very foreign to SQL, but it's something that's very like natural to data frame libraries, and that's the idea that data has like an intrinsic order, right? Like my row 1 is row 1. It's not just a row in a database, right? And DuckDB does its best to maintain this order through like insertions, through deletions. Like it doesn't just reshuffle the rows, right? Similar to how a data frame library won't do that. And that's one of the things we're introducing as well is the positional join, which essentially joins based on this row. So it will say, okay, the first row from the one side, from the left side goes with the first row of the right side. And then it will just kind of like join together and potentially fill with null values if they don't have exactly the same amount of rows. And this is the syntax for that that's going to be added. Cool, all right. Well, thank you very much for listening. Then I will hand it back to Hannes to talk about, well,
where we are. Thanks, Mark. Yeah, this has been, of course, a wild ride, so can I take it down a bit on speed? Let me talk about some easy things. So first, Mark has already mentioned it briefly. Oops, wrong direction. We have a company now that is bigger than 0 people now, called DuckDB Labs, and it's basically where the core DuckDB team works. And we're all in our Amsterdam office, and it's a self-funded, bootstrapped company. So we are basically raising money through strategic partnerships and essentially helping people with their use of DuckDB. DuckDB Labs also maintains some extensions. So for example, the SQLite and Postgres extensions came out of the company. At the moment, we are about 15 staff plus various contractors. So I think that's also a big change from last year, is that we went from sort of a small group of people that hack around together from a company that has to work. we have an office, and we're so proud of our new office that we had somebody come in, take pictures to show you. This is Mark in his natural habitat. Based on the headphones, you can see he's currently talking to somebody on the internet. I will not disturb him. This is me, you know, in my gallery of duck pictures and looking out the window because you can actually see some boats there, and I like boats. So. Here's some pictures from our offices. This is Sam and Pedro working very hard, of course. Here's Lawrence, Tom, and Tanya working. And so this is, yeah, we have kind of chosen for a bit more traditional sort of structure where it's not everybody's in a random place around the world, but where we actually are together in our office. And I think it's part of the reason why we're able to move so quickly is because we can just, you know, yell at each other over coffee if we have a disagreement instead of writing passive-aggressive emails. So, you feel seen. No? Just, what also has really changed a lot in the last year, despite us, besides us getting an office, is the adoption of DuckDB. And you know, I think this. I feel a bit dirty by saying this because it reminds me of like how many Mac users there are in the world and whatever. But we've seen quite a tremendous growth in DuckDB adoption. So, for example, on the and again we have a recursive slide screenshots here now. Like this was the very first one we did, the second one, and this is today. So we have about 1 million installations a month now from Python alone. Like that is just wild, you know. Like just from pip downloads, pip install DuckDB, and that has gone up from about 150,000. What also really surprised us in the last couple of months was the amount of Java downloads that we got. So you know, DuckDB has a JDBC driver. It's special because it's not just a JDBC driver like your normal database, but of course the entire database lives in that JDBC driver. So you don't actually connect to something. You run DuckDB inside your JVM, which is wild. And that has gone up from something like 6,000 downloads in April to 600,000 downloads now, which I take as a good sign of DuckDB's adoption in the enterprise, because I think that's where the Java people still are. We also saw a lot of uptake in Node downloads, and yeah, also a lot of more direct downloads. There's some things we can't really track very well because we are not evil. We don't have telemetry in DuckDB. Like there's no like callback features or anything like that. We literally do not know who is using DuckDB. And there's some front ends like the WebAssembly one that is also, you know, in case you're not aware what it does, it's running DuckDB inside your browser completely using WebAssembly. But that usually people just render into their web application and we see one download and there might be thousands of people using that one thing. The same is also true for if somebody downloads our C++ library and bakes that into an application, we see one download and then from there on out. What also has changed a lot is I think the number of GitHub stars has kind of doubled. Twitter followers, I'm quite happy to report that despite Twitter being called dead multiple times in the last year, there's still quite a lot of people there. And what also I think has been quite successful is our Discord channel. So in case you're not yet on our Discord channel, which probably you are because you're here, but you can go to discord.duckdb.org and you will, you know, join that. And we have about 2,000 people there on that Discord server, I think is the term. I'm sorry. And just in terms of how is this all governed, because obviously DuckDB Labs is a commercial company, but DuckDB is an open source project. Now, how do you combine these two things? So the DuckDB project itself, so DuckDB, the open source project, is actually owned by a non-profit foundation, the DuckDB Foundation, which also, by the way, runs this event today. And that foundation is there to ensure the long-term survival of the project and to disconnect also the project from the commercial company. The foundation basically runs the project. It has there's a roadmap that is for the project, for the open source project that it funds. And yeah, as I said, all the IP, all the name and logo, all that stuff, that's in the foundation. And the foundation is a non-profit, and for example, it is in the statutes of the foundation that DuckDB has to remain under the MIT license. That is one of the things that we wanted to make absolutely sure that no matter what happens, this is kind of ensured. And commercial users of DuckDB, and if you're one of them and you're not on the list below, feel free to be encouraged to donate to the foundation. We have been very generously supported by the following organizations. So there's Voltron, Data, Relational AI, Modern Analytics, MotherDuck, and Posit have been donating on the gold level, and we have Hex, Watershed, Notable, Real, Omni, and Liquid Analytics yesterday on the silver level membership, and we're really, really thankful because these donations allow us to run a large portion of the open source projects sort of independently of the company. And it allows the project to have its own life, and it doesn't have to kind of bow to our commercial goals. So it's really an important thing, I think, especially in that context of this very common, let's say, conflict in an open source project that is run by people working in a company, and you get all these kind of weird effects, especially when the company is trying to raise money, which we don't because we're self-funded. Okay, so that was the adoption. How's the time going? Very good. So where are we going? Some of the things have also been mentioned already by Mark when he was looking at the first back slide. I don't know what you call this. So what are we going to look at? And I know we have been promising this before, and we're sorry that it hasn't happened yet, is the storage format finalization. But I think from listening to what Mark has said about how much things we have been doing on the storage format, it doesn't surprise you that we haven't, maybe it doesn't surprise you that we haven't said yet this is the format that we're going to commit for forever and never break again, because it's like quite a lot of like technological anxiety actually to kind of commit to a storage format for the next 10 years, and we want to get this right. And it's probably going to happen like this, that we just, you will not see sort of things a long time, and at some point we'll just miraculously declare it stable because we just haven't changed it in so long that we're comfortable that it's now stable. Mark has already also talked about out of core, and one operator that is still left that we still have to make out of core capable is the aggregation operator, and we're gonna want to work on that because it's also the last operator that is not out of core capable. So I think we promised you out of core last year. We did all the things except for aggregates, and I do have a very hacky branch that does it, but I have not enough time to code these days, let's say. We also want to add the partition awareness to DuckDB. Basically, there is, as we've seen for the Hive partitioning, for example, there are data sets that have partitioning in them. And while our Parquet reader, for example, thanks to some, also already eliminates partitions that cannot match due to the predicates in the query, we want to add awareness of the partitioning to the query plan in general, to the statistics in the query plan, because then you can also be clever. For example, if you know that your scans are already following some partitioning scheme, you may not have to kind of combine hash tables across threads because you know they can never have competing entries. The same holds that we want to add awareness of sorted data. Lots of data out there happens to be sorted. And if we can shove this through the query plan, this information, we may be able to exploit it. For example, if you have a window function that specifies a sort order that happens to be already given in the data that comes into the query, well, we don't have to sort. That's the cheapest sort ever, right? Something that's also has been we have gotten a ton of requests for is to add support for lakehouse data formats. Now's the time where I can complain that I really don't like the term lakehouse. But I think the data formats that the lakehouse people have generated, they're here to stay, or at least they're emerging, and we get a lot of requests, so we're probably gonna add some sort of support for them. I think we're probably gonna start with Iceberg. Then there's also a lot of requests we got, and actually quite active Twitter discussion on support for spatio-temporal data, so data that has geographic positions in it, like latitude, longitude, and the time. And Max has been working very hard on an extension. Remember, we have extensions, so this is going to be an extension to DuckDB that adds support for these data formats and adds specific operators. For example, so you can do spatial joins or aggregations, things like that. And some smaller stuff. We also would like to add these as-of joins to better work on time series, where you don't have a join that doesn't have exactly matching tuples, but you kind of want to find the nearest, the closest tuple to the join partner. And also, there's also a long-standing thing that we have on our list is to support pivoting in like the thing from Excel. So people love Excel a lot, and so because it's not there in DuckDB, we get a lot of requests for it as well, and we of course always listen to the people. So we might add this. Okay, so with that, I'd like to open the floor for